let's just assume that this is true and move forward. So if these are the eigenvalues and eigenvectors, and I've been asked to evaluate this, then the formula that we need to be using is that our final n vector is going to look like a constant times, and let me number these, that'll be lambda 1, lambda 2, x1, x2. Our formula is going to look like c1, x1, lambda to the 10th, plus c2, x2, lambda 2 to the 10th. And again, it's because I'm looking for a to the 10th that we end up with a 10 in both of these exponents. So we already know what our x and lambda values are, but to get the c1 and c2, that's where we're going to use the diagonalization formula for a. So if a is equal to p inverse, PD p inverse, where p is the matrix formed by my eigenvectors, we solve for the c1 and c2 by doing p inverse times whatever our initial vector was, so 10, 2. So now we have to find p inverse and do this multiplication. So p is going to be the matrix that's formed by my eigenvectors, and the order matters. So because I've specified that this is lambda 1 and x1, and this is lambda 2 and x2, it's important that I put my 1 in the first column and my 2 in the second column. So I've got 3, 1, 1, 1. So to find p inverse, I need 1 over the determinant, and our determinant is 3 times 1 minus, so I've got 3 minus 1, so that'll be 1/2. I flip the primary diagonal, and I make the off diagonal entries negative. So my p inverse matrix, distributing that 1/2 through, is going to look like 1/2, negative 1/2, negative 1/2, and 3/2. And that is what I'm multiplying by 10, 2. Just to give myself a little bit of space, I'm going to move that out of my way. So multiplying that out, 1/2 of 10, that's going to be 5. And then negative 1/2 times 2 will give me negative 1. So 5 minus 1, that's a 4. Negative 1/2 times 10, that's negative 5. Plus 3. Did I get that right? Negative 5 plus 3, so negative 2. So that's now my C1 and C2 values to plug into the formula. So hopefully we can read the green, but I know that a to the 10th times that vector 10, 2 is going to be equal to, so C1 is 4, so 4 times our x1 vector, 3, 1, times lambda 1, which is 1, to the 10th, plus negative 2 times my x2 vector, 1, 1, times lambda 2 to the 10th,